functions that look like this?
No. Yes.
That are extra curvy?
Yes.
Aren't you tired? Aren't you tired, Lily, of just parabolas? Day in and day out, another parabola.
It's a cubit.
Wouldn't you like something that could take you higher?
I to the x power.
I love those.
Go
I to
faster?
the x power.
With more ups and downs? Wouldn't you like that in your life?
Up and down.
Can I get an amen?
Like you can take a
All right. So we are going to study higher order polynomials now. We've spent a lot of time with quadratics. And you guys know like all there is to know about them. You can graph them, and you can find their zeros. You can find their intercepts or whatever. You can find their axis of symmetry. You can right all sorts of wonderful things. Graph them. Okay. So we'd like to talk about higher order functions now too, and that is the subject of all of topic 2. Let me just remind you, in the warm-up today, you solved these 2 problems. I'll just put them back up here again. Here they are. Boom. And boom. The first one was quadratic, but the second one had a cubed in it, which is like, how do we even deal with that? Like, what is that? I don't know. This one up here, if I asked you again, just like we talked about a second ago, if I asked you to plot that, you should be able to do that. If I asked you to like solve that for the zeros, you could do it. If I asked you to find the axis of symmetry or whatever, you could do all of that. But suddenly, if I ask you anything about this, you basically know nothing. Right? Like if I ask you what this looked like, I don't know that you have any intuition about that yet. We're gonna build that intuition. You're gonna be good at this. Find the zeros, solve these things. Is there any important points on them that we should identify? All those kinds of things are like still questions for you, I think, that are up in the air. And if that doesn't excite you about the future of this class, I just don't know what will. Right? I mean, don't you desire in your innermost being to like think about this kind of function? Just say yes. All right. On your handout that I've given you kind of a note sheet. It gives you this. This is where it starts. Yes. Okay. We're going to introduce this new kind of function. It's called a polynomial. Is the thing to put in that first blank. And I should tell you that each of these things along the way, this 2x squared or this 2x or this negative 12, those are called monomials. Monomials. You know the word mono or poly. What does poly mean?
Multiple.
They are Greek prefixes. What does poly means? What did you say?
Many.
Many or multiple? Yeah. What other words? Not just in math, but in life.
Polygon.
What else? A polygon means many sides. What else?
Venus.
What?
Polyphemus.
What does that mean?
Odyssey.
Except
Yeah,
he
but-
only had one eye, which is ironic. It's ironic.
Okay.
Polyamorous. That's what I was thinking.
Why is that the first word you go to?
I was just thinking
English class.
polysexual.
What else?
Polynomials.
What else?
Polyatomic eye?
Huh? Polytheistic. Right, many gods. Sorry, we've talked about religion way more than I expected we were going to today. All right, polytheistic. Yeah, many gods. What else? What does that mean?
That means it's an ion
Polymer.
more than one atom.
A polymer.
Yeah, a polymer. Ask your chemistry teacher what these things are. Okay. What else?
Polygon.
Polygon, we already said. That's a shape of waves.
Polygon. The Pokemon.
Anyone else have a poly word?
Polymer.
We already said that one.
Polyester.
Yeah, polygamous. That's right.
I already
Means many wives.
polyamorous. And
Um,
I said polygamous first.
What? Anyone else have one? I'm not sure that's in the spirit of the Greek, the derivation of the word, but we'll go with it.
Polytheistic.
Yeah, we said polytheistic
No,
too.
I said
Poly was more than one cracker.
What other ones can we think of? Polysyllabic means multiple syllables. There you go. Polysyllabic words, more than one syllable. What else? Yeah, polyglot is someone who, do you know what that is? A person who, yeah, someone who speaks multiple languages is called a polyglot. Yeah, there you go. So, Greek for the win. Whole numbers is the next blank. What's that say? It says the exponents all are whole numbers. Now, to be clear, I want to make sure you're not like thinking that we're being like mean or like pejorative toward functions that have exponents that are not whole numbers. Okay, just want to make sure this is like a judgment-free zone. Those are perfectly good functions too, but they have a character that is very, very different. Their behavior, their graph, all that, than the kind of thing we want to study, which is these nice smooth curves, these polynomials, okay? So feel free to explore those functions. They're interesting, and we will study those functions for sure. But if it's going to be a polynomial function, then we want all those exponents to be whole numbers. And by whole numbers, remember, we studied this recently. What do we mean by whole numbers? We mean 0, 1, 2, 3. We mean not numbers such as 1.5 or what else is not a whole number? What was it? So out of there. Yeah, negative numbers or irrational numbers, all are not okay as the exponent. Okay? And then also fill in this blank. The coefficients, though, we have less restrictions on, can be any real number, okay? So negative for the coefficients, that is like here we have -5, for example. Negatives are cool. For the coefficients, rational numbers, irrational numbers, all okay. Yeah, pi could be a coefficient, sure. For this polynomial right here, the leading coefficient is this thing out front, right here. The an is the leading coefficient, and a0 down here is the constant term. So, for instance, up here we would say the leading coefficient of this polynomial right here that we have is 1. Yes, isn't that the coefficient on the x to the third? Wouldn't the leading coefficient of this be 1? You might be thinking, why do we care to call it something? But I promise, the leading coefficient will be very, very important in your life. In some ways, you already know that, don't you? Because you kind of know what that value does for a parabola, right? That leading coefficient. You already know how important it is. So that's going to be actually true for higher order polynomials too. So that's why we want to single it out and give it a name. That's called the leading coefficient. The last thing there, 5, would be considered the constant term. Yes. And are you okay with the subscripts? Here, I know this. When you first look at this, you're like, "That's a lot of letters." But I want to make sure you actually understand that this is a really nice, efficient way of naming the coefficients for a polynomial. Imagine that I had like a 15th degree polynomial, like x to the 15, like 2x to the 15th minus 7x to the 14th plus all the way down to some constant, right? Imagine if you might be thinking like, can't we just like name the coefficients a, b, c, d, etc.? That would be okay. You could. You're okay with that. But the reason I like this better is that if someone with that like 15th degree polynomial was like, what's coefficient? What's g or something? I'd be like, a, b, c, d. Oh, okay. So that's. I don't know. But if someone says like, what's a7? I'm like, oh, do you mean the coefficient on the 7th degree term, the x to the 7th? You see how that's helpful to name them? It's also lazy. It's just like I don't feel like thinking of all the letters, right? Let's just call them all a, and we'll just subscript them by whichever power they're on, right? If it's the x to the second term, let's call that a2, the coefficient on front of that, right? Is that a cool way to do it? So I know that at first this looks a little scary to see this with the triple dots and the ends and all that, but I just want to make sure you understand. That's actually it's trying to be a convenient, choose a convenient notation actually. So like, so A3 here, A3 would be 1. Yeah, we already said that. That's the leading coefficient. What's A2 for this guy up here? For this guy?
-x squared.
Well, just the coefficient is all I'm asking. A2 is a coefficient.
-1.
So -1 is A2. Someone else? A1?
-5.
And A0, somebody else? 5. Right? A0. Why is A0 a good name for that guy, the one at the end? Is that the coefficient on the x to the 0 term? What's x to the 0? Regardless of the value of x, it's 1, isn't it? So actually, in some senses, you could actually, if you wanted, write this as 5 x to the 0, right? But we don't do that, do we? Just because we just don't feel like it. But you could. Just like here, you could. This 5 is -5 is a1, isn't it? Yeah. Well, is this x to the first? Yes. We don't write the 1, but you could. Right? So I just want to make sure that that naming convention makes sense all the way through, actually, even at the very end with the A0. If it's in order like this, it's called standard form, and make sure you're filling in these blanks. And the degree of the polynomial is just the highest degree in the equation. So, for example, the one we have here is a degree 3 polynomial. Yes? And all the ones we've been working with for the past month have been degree 2. So quadratic, also known as degree 2 polynomial, or a second degree polynomial.
We don't consider the plus 5 as like a third degree polynomial? Like
No, I mean, some people might be tempted to be like, okay, well, there's x to the third, there's an x to the second, there's an x to the first, so this should be like this should be like a 6th degree polynomial,
What?
or something. I don't know.
Multiply
You want to
it?
like, or I don't know.
No.
I'm just adding up the exponents or something. Don't no. It's just the highest degree term that we care about.
Oh, the highest.
So if it's the highest degree that appears is a 3, that's a third degree polynomial. All right, so here are some examples that are on your sheet too. The first 3 rows of this table should be like utterly familiar to you. Do you agree? Right? Constant functions are not very interesting, though we have talked about them. Linear functions, you talked about a whole bunch in Algebra 1, so I feel like you should be comfortable with seeing linear functions, with plotting them, with understanding their behavior, etc. Quadratic functions, we've just talked a lot about recently, and so there's one there. And no matter how messy those are, you should know basically everything there is to know about them at this point. But then the ones down again, let me say this again, you should be just hungry for knowledge when it comes to these last 3 rows of the table. Shouldn't you like desire to know what those look like? How they behave for large and small values of inputs that you put into them, how they look in general, how to solve them if you set them equal to 0, and you how to find the solutions. These are all like really interesting and sometimes hard or even maybe impossible questions. So take a look at those. I've tried to give you like a variety of things to look at there. And I've also given you the names of these functions too, right? The first 3 I think are familiar to you, but these are new names to you: cubic, quartic, and quintic. And then after that, if you want to name like a 7th degree polynomial or something like that, we might just call it that, a 7th degree polynomial. So we don't have names after that really. Which is fine. Yeah, don't you desire to know like what these could be good for? What real world contexts might there be for these? One other thing to notice too is, for example, for this number, for the cubic here, what is A2? That is the coefficient on the second degree term, the second order term. What's A2?
0.
Is that allowed? Is 0 a real number?
Yeah.
Yeah, it sure is. So I just want to make sure you're clear. Like, just because the examples we've looked at before, and maybe it seems like maybe we need all the powers, but we don't. Is this still a valid polynomial? Yeah, absolutely it is. If some of the coefficients along the way are 0, that's okay, right? It's okay. So notice A2 is 0. Also, what else is 0 for this guy? A1 is negative 15. A0 is also 0, isn't it? And that's okay. Yeah.
If 0 is a valid coefficient, then does that mean that f of x equals 300 is also technically a polynomial?
These are all polynomials.
Oh.
Yes. So yeah, to be clear, thank you for bringing that up. Every single one of these is a polynomial, right? That is has some has multiple terms in it, right? And so it could be just one. Is under this is an umbrella term. Polynomial is all of these things, including things that we studied before. These particular things we studied before. And then the other piece of notation the word we introduced earlier a second ago was standard form. Are all of these in standard form?
No.
And if not, someone else that I haven't heard from here, tell me. I'm hearing some of the same voices here. So, is there one that you see that's not in standard form? Maybe point it out. What do you see? By standard form, we mean from highest power down to the lowest power. Put in that order. Someone I haven't heard from.
Isaac has a book.
Go ahead, dude. Yes, you have.
Oh, yes.
Huh?
Oh,
The quartic. Yeah, this guy's not in highest to lowest order, right? Powers. Powers is what I care about, right? Okay. Is that it? The other ones are in standard form. There's another one?
Yes.
Jordan. The second one? The linear one, yeah. This is technically not in highest power to lowest power order, is it? All right, when you're ready, go ahead and try with your group of problems that are on the bottom of that page, okay? First question to ask is it even a polynomial? Does it even qualify for the definition that we gave up at the top? Read it carefully and make sure that you actually understand the technical, precise definition of a polynomial.
Okay.
And then if it is,
Yeah.
then you can answer the other questions. Give the, name the degree. The definition of a polynomial is at the top, right? So it will be for, it should be something of the form real number times x to a whole number power plus real number times x to a whole number power. That's the only thing we consider a polynomial, right?
Okay, so I made them, but
Yeah.
Stay strong.
Yeah, first one is
so it's minus 1 times x. So did I do x?
it wasn't steroids, it was blood.
Still similar anyways. A is x. No.
You should know your history.
So this is the same thing.
I'll go with you.
This x plus y.
Well, how you go?
Y.
Okay. What if we just did
Give you another minute, maybe?
we do 3 and then x plus 3 to the power of x minus 3, and that should be 3 and 3x minus 3.
Check your answers with the other people in your group too. If you're not already talking with people, talk with them. We'll go over these in just a minute.
I'm glad I didn't do that. Find the like call there. So what's the quart? Like quarts, like what? 4 quarts in a gallon or something, or like? Right?
Sure.
I don't remember. Let's do like that G and then
Oh, there are.
yeah. Okay. Oh, gallon, man. Gallon. Oh, true. Second grade.
Yeah, that means it's
Read carefully what it means for it to be in standard form.
Descending order. Oh, gotcha. So it had to be minus 3x plus 1/2 x squared.
Alright, we're gonna go over these. Ready?
You're gonna be in the grades with 4.
Set.
This is the highest number. So you want to go faster.
Alright, here we go. Let's I know some of you are still working, but I think a lot of you are done or close enough. Decide what'd you say about that first one? A is it or is it not a polynomial? Can you just say it one more time louder? It is? Why? The coefficients? What other tests does it have to pass? And are they? Okay. And then, so yes, this is a polynomial. Can you write it for me in standard form? Or is it already? I don't know. How did you write it in order here? Did you do it? You want me to come back to you just back?
Do 3x and I think 4 minus 1/2 x.
Close. Careful when you're rearranging to whom negatives belong. Yes. Pay attention to whom negatives belong. Is that okay? What's the, and then just verbally, what's the degree?
4.
Josiah, what's the degree?
Quadrant?
Yeah, that's the type, or the degree is degree 4, yeah. The type is quartic, he says. The leading coefficient is,
3.
yeah, -3, and the constant term is, he's got, what'd you say? Did you say it? Oh, no. Yeah, the ladies at your table helping you out. That's good. Yeah, all those are those are correct answers. Good. I mean, this is still new territory a little bit for us, so that vocabulary we're getting used to. Keep in mind that the leading coefficient for A, the leading coefficient is not a half, right?
Wait.
The leading coefficient is -3, okay? The leading coefficient is, in this case, A4. Yes? The coefficient on the highest degree term. That's the leading coefficient, regardless of order that it might be written in. Once we put it in standard form, it is obvious that it's the first thing, though. B, is that or is that not a polynomial? Is right in front. I got
Yeah, it is.
okay. And appeal to the definition for me. Why is it?
Because the exponents are whole numbers and the coefficient is.
All right. So I know this is a little bit of a nuance, but are all the exponents whole numbers?
Oh no, there's x.
Yeah. Yeah, we can't have like a variable. We're looking for exponents that are all constants that are whole numbers, right? So this is actually not a polynomial. It is, again, I don't want to like be mean to this function because it is still a function and it is still beautiful, right? And it still has its own life. And so, right? It's wonderful. It's a wonderful function. It's just not a polynomial function, okay? What is 3 to the x, by the way? What kind of function is that? Yeah, it's exponential. And so what is this together? I don't know. Like a polynomial exponential hybrid function. I made that up. Okay, I don't know. But it's not a polynomial. It's not really purely exponential either, but yeah.
Wait, so is x gonna be like imaginary? So this is like x has to fit on like a plane that's only like real numbers?
Yeah, we're gonna take x to be real in like in these
okay.
discussions right now. Yeah, but I'm not sure why. Does that matter? Why does that matter?
I don't know, it's like, isn't there like the complex number plane and then there's like the x and then there's like the y, so when x would be like, it can be like a y, or like.
Yeah, let's not get too confused about that right now.
Okay.
I do have things to say about that. I just don't feel like saying them. Okay. Jordan, what about C?
No, because that's -1.
Okay, and he gave a reason. Because that -1 power, we said the whole numbers is what that. The exponents need to be whole numbers, we said. So, what about D? Ajit, what would you say about that one? Okay, give a reason. Pi is not what? You just trailed off a little bit. Oh, discussing. Okay, deliberating. Big question. Huge question. I'll give you a hint. We are trying to trick you up with this. Right? What is it?
Wait, what? Wait, you were?
I know it's ironic.
Oh man, my mouth almost told me to choose another.
All right, what's the answer? Are you guys ready for the climactic answer from a G? Okay, let's say it again. Wait, guys. They're asking you complete silence for a Jeet's answer. It is? Why? You're not talking very loudly. I just want to be honest with you. Okay. Yeah, and we were trying to like really trip you up there, right? But it is true. All of the coefficients are real numbers. Pi is cool. Root 2 is a real number. Are all the powers positive, like whole numbers, right? Are they? Yeah, I think they are. So I think that is a polynomial. Do you want to write it in standard form for me? Go for it. So what kind of polynomial is this? Yeah, it's degree 2. It's a quadratic, right? So, by the way, so that tells me, actually, hey guys, this would have been fun. Do you think this would have been fun to see on your test yesterday? I could have said, plot this, or I could have said, find the zeros. Could you have run the quadratic formula on that? Absolutely. Actually, you could have, right? You could find a vertex for me, right? It'd be all of the answers to those questions would be messy, but it is just a parabola, isn't it? Yeah. Even though in the end it looks a little messy, it's not. It is just a parabola. All right, we are coming close to the end of the period, but what I'd like to have you do tonight is actually start exploring the behavior of these functions, right? We're going to start with some of these simple examples down here, and we're asking kind of some simple questions about how large they grow and rates of change. So I'd like you to do this exploration a little bit on your own. We're going to talk about it a lot tomorrow when we come in and make sure you guys are really good on this stuff. I'd like you to think about what happens if x is small on number 2. I'd like you to think about what happens when x is really, really big. What kind of behavior do we have? I want to get some of that like informal stuff going. So give it a try. Think about what you know about linear and exponential functions too along the way. I can't wait to talk more about this with you.